All right, here we go. This one's for Rachel. This is your favorite problem, your favorite type of problem. Anywho, we got to get rid of that radical in the denominator, which we're going to rationalize. And let's go ahead and multiply by root 10 over root 10. All right, so there we go, root 10 over root 10. I apologize, I got a little sniffly here, so I might have a few of those going. That's kind of gross, but bear with it. So multiply by root 10 there and root 10 there. Okay, we'll clean that up a bit, and it's going to be 4 root 5 times root 10, so that's going to be 4 root 50 plus 2 root 2 root 10. 2 times root 2 times root 10, that's 2 times root 20. All right, and that'll be all over 10. Because root 10 times root 10 is 10. Of course, that's the whole point to do that. Now, I want to try to get rid of and reduce that 10 in the denominator if I can at all, and also simplify the radicals. So in order to do that, I have to try to factor out the greatest common factor, or a factor of 10, 2, 5, or even 10 itself, from the numerator. So in this numerator, I'm just going to clean this up a little bit. Square root of 50, that's the same as the square root of 25 times the square root of 2. So this is really, all this is the same as 4 times the square root of 25 times the square root of 2. All right, and that turns into 5 times 4, which is 20 root 2. Okay, so that's now going to be 20 root 2 plus, let's clean up the other term, that's going to be 2 times the square root of 4 times the square root of 5, which is 2 times 2, which is 4 root 5. So that one ends up being 4 root 5, and that stuff is all over 10. Okay, so there's a couple ways to look at this, but you certainly can't just cross off the 20, cross off the 10, and turn a 20 into a 2. That changes the value of the expression. So what I'm looking to do here is to factor out something that's common with 10 from the numerator. And so each one of these terms has a greatest common factor of 2. Well, actually 4. But 4 is not a factor of 10, so it's not really going to get me anywhere. So I'm going to factor out of there a 2, because I know that 2 is a factor of 10, because 10 is the same as 5 times 2. So I'm going to take a 2 out of here. So if I take a 2 out of there and I undistribute, what's left then is 10 root 2. And if I take a 2 out of here, what's left over here is 2 root 5. Okay? So I'm like doing distributive property backwards. So now what do I have is 2 factored out, and inside parentheses 10 root 2 plus 2 root 5. And that would be all over 10. Right? So I took a 2 out of there, and now the whole purpose of doing that was to be able to reduce that 2 with some of this 10, and that will leave 5 left. So really, the best we can do here is 10 root 2 plus 2 root 5 all over 5. And I'm not going to be able to simplify that much more. I could break it into 2 parts here. Because of the addition, I could break it into 10 root 2 over 5 plus 2 root 5 over 5. And then, of course, right here, the 10 and the 5, you can reduce that, so that just becomes 2 root 2. So, this is just getting kind of crazy out of hand. But 2 root 2 plus 2 root 5 over 5. I mean, I don't know, is that really simpler? Kind of debatable, I guess, but actually the same value, if you type that in the calculator, that would be the same value as this stuff right here, which would also be the same value as this stuff right here. If you type that all in the calculator, you would get the same exact decimal approximation for every one. If on the test tomorrow you can go ahead and say, oh, I got that, I can do that, that would be great. That's impressive. I'd be impressed. If you can do that, wow, that's great. I'm impressed. Okay, there's a lot of manipulation going on right here, and so hopefully you do your best. That's it. Thanks.